Hey, what's up guys? My name is Saurav and this is my YouTube channel Data Science Novice. So if you are new to this channel, please do like and subscribe. Your efforts are massively appreciated. So this is the third project in the series of data science projects. The previous two projects were on regression and this time I have chosen a project on classification. So if you haven't watched those videos, go ahead and check them out. So this is a project on classification where we have to classify whether a person will default or not. So here default means that the person will not be able to pay the loan. So this is going to be our first project on classification, and by the way, I am also working in this domain. So now let's talk about what we are going to learn from this project. So first we will visualize the data, and using those visualization we will do a thorough analysis. And along the way we will be writing some queries to get a better understanding about the data. So it is going to be a mix of visualization and queries. And along the way I will try to impart the knowledge on what I have learned from the industry. So we will be talking about particular analysis and then we will move on to next analysis, and we will see how with this just analysis we'll be able to find many things. Next, we will move to the data cleaning part, and that involves dealing with missing values, removing duplicate columns, dealing with categorical variables. And this time, we will not be using the previous techniques in the project we have talked about so far. We will be developing new techniques so that we can learn more and more techniques. So once the data is ready, we will build some model. And this time I'm going to show you a different approach for model building. We will be able to build 4 models in just 4 lines of codes. And you will see that how convenient it will be. Also, we will be building a deep learning model as well, just to show you a point that will help you in future projects. And finally, we will see that how we can deal with the imbalanced data set. And in the analysis part, I will talk about why imbalanced data set is a problem. So let's get started. So here I am in Jupyter Notebook and I have already imported the libraries, data and metadata. The data and the metadata is on my Google Drive and the link is in the description box. And don't worry, I have allowed the access, so go ahead and download it. And if you want to know more about the data, you can visit my GitHub account. I have already written about it there. So now let's check the metadata first. And here you can see that we have variable and their description. And now if you want to get the description of any variable, what we can do is we can call the description column, and on that we can use the indexing, and that will give us the whole description of that particular variable. And like this you can play around with the number and you will get the information about that variable. This is going to be very helpful when we want to know about a variable. Now let's check the shape of the data. So we can call df.shape, and you can see that we have 3,96,000 rows and 27 columns. That means we have 26 features. So this data set is quite big in terms of data points. So we can say that we have enough data points. And now let's check whether the data uploaded correctly or not. And for that we are going to call .head method, and you can always use .t to transform the data. This way we are able to see all the columns. That is not the case with when we call df.head method. So the data has been loaded correctly, and one thing you will notice that most of the columns are categorical in nature. So try to understand each variable because this will give you a lot of domain knowledge that fresher lacks. Now let's begin the analysis part. So the first thing we should always do is look into the distribution of target variable. And since target variable is categorical in nature, we are going to plot count plot using Seaborn library. And for that we just have to call sns.countplot. Then we have to pass the target variable, that is loan status. And then we have to pass the data itself. So with the help of this graph, we can see that we have more example of fully paid than the charged off. And if you don't know what is charged off, just consider that charged off means didn't pay the loan. As of now with this plot, we don't have actual number of count, and we can always code that, but we are not going to do that because doing this thing is quite tedious in Python. And even in industry, no one uses Python for data visualization. And the reason being it is quite tedious. And we have to write a lot of code for doing a simple visualization. So in industry, we have tools like Power BI and Tableau, and people prefer them because doing visualization in these tools is way faster than doing coding in Python. So to get the exact count, we are going to use value count method. So first we have to get the column, and on that we just have to call value count method to get the intended result. So here we have the actual count and we can see that there is a huge difference. But if we want to have more information that can easily be interpretable, and for that we are going to convert them into percentages. So let's multiply by 100 and then divide it by the length of the data set. So now we have a better understanding that we have a ratio of 80 to 20. And this is a very big problem. This is called highly imbalanced data set. Since we have more example of fully paid, and this is something not good for the model because model will be trained on more data from fully paid. So it will be biased toward those things. And we will be talking more about the imbalance thing in modeling part and we will see that how to tackle this problem. So the first thing from analysis and data visualization we realized is that our data set is highly imbalanced. Next we are going to visualize the loan amount. And since the loan amount is continuous variable, we have to use histogram. So first we are going to set the plot size which is going to be 12 by 4 and next we have to call the histogram. So sns.histplot and then we have to pass the data and we can pass the data like this or we can use a rear method. And next we are going to decide the number of bins. So this is something you can play around with. So in this case I'm going to go with 40 and now you can see the visualization and if I change it to 50, now here we have this graph. So from this histogram, we can observe that it has right skew distribution because it has a long right tail and it is also known as positively skewed distribution. And if we look at the extreme right, we see the value of 40,000. So some people have taken the loan of 40,000, which is an outlier. So next we are going to create a heat map, which we saw in the first project as well. And it is nothing just a better way to visualize the correlation matrix. So let's first define the figure size and for that we are going to copy paste the code and I'm going to change it to 7. And to plot the heat map, we just have to call sns.heatmap. And it takes few parameters. So first we have to pass the correlation matrix and that can be calculated by simply calling the correlation function on the data frame. Then we have to set a0 equals to 2 to get the correlation value. And then we choose the color map for our heat map. And in this case, I'm going to choose where it is, which is something I like a lot. So here we have correlation heat map and it is only plotted for numerical variable. So here the yellow color represent the correlation of 1, that is positive correlation. And the dark violet represent the correlation of -1, which means negative correlation. So the first thing that we see that loan amount is highly correlated with the installment. And the reason being installments are calculated on the loan amount. Hence we see a strong correlation. Next we see that open account is positively correlated with total number of accounts and that is understandable since more account you have, chances are high that most of them are going to be open account. Similarly, try to draw conclusion from these graphs because when interviewer asks you for the project, he is looking for these kind of analysis. So spend some time on this, give a thorough read. So since we saw there is a strong correlation between installment and the loan amount, it's a good idea to visualize it using scatter plot because that will give us more clarity on how the relationship is working. And for that, we just have to call sns.scatterplot and inside that we have to pass three things. So first we have to pass x-axis data and that is going to be installment. And for the y-axis, I'm going to consider loan amount. And then finally, we have to pass the data set itself. So here we have the graph. So let me make it a little big. So just copy paste this line of code here and just paste it here and then rerun the cell. So here the graph looks like disoriented V that is filled. So now if we try to relate it with the real life, what we can conclude? We can conclude that the loan installment is different for same loan amount and there can be many factors like someone has taken a loan for let's say period of 10 years and someone might have taken the loan for let's say period of 15 years. And when we calculate the installment, we make use of number of years and the interest rate. So that's why we are seeing this kind of graph. Next, we are going to see how the loan amount affect the target variable, that is our loan status. And for this, we are going to use box plot. And if you have watched my previous video, you know that it can be used for outlier detection as well. So sns.boxplot and then we have to pass the data. So on x-axis, we are going to get the loan status and on the y-axis, we are going to get the loan amount and then we have to pass the data itself. So if you don't know about what is box plot, it is good time for you to explore it. So the line inside the box is median, and we see that median loan amount is almost equal. So based on this, we can make an assumption that the loan amount is not a good factor in deciding whether a person will default or not. Note that we are making an assumption and it could be wrong or it could be right, and we will explore this thing in modeling part as well. Now, if you are not comfortable with the graph, there is another way we can get this information. And for that, we are going to use group by function. So we group by the data based on loan status. Then on that, we are going to call our loan amount. And on this, we are going to call the describe method to get the statistical summary. So it will give us the same summary that our box plot is giving. So here we see that we have the count, then we have average amount for each category, then we have standard deviation, and then we have minimum value. And here the 50% represent the median value. So now if you look at all these numbers, all of them are comparable. Hence we are making this assumption that I talked about earlier. Next we are going to explore the grade variable. So let's call this variable. And here we see that it has alphabets like A, B, C, D. So basically it's a categorical column. And now it's a good time to look for the information in the metadata that what is grade variable. So the grade variable is on the fourth index. So try to call it and then copy paste the content on Google and try to find out what it is. So just to give you a gist of it, it is just a grade given to a particular loan. If the person is paying everything on time and doing everything right, the customer is assigned grade A. Next, we are going to call the unique method to get the number of values this variable can take. And here we see that we have grade between A to G. So basically we have 7 unique values. Now let's plot the grade variable with loan status and see how the grading affects the loan. And for this, we are going to take the help of our old friends count plot. And in that we have to pass the grade. And then we have to pass another parameter that is hue. And in that we have to pass the loan status. And as usual, we have to pass the data. So this looks quite small. Let me change the shape of this graph. So here we see that this count plot looks different from all the other count plots we have plotted so far. And the reason being this time we have passed the hue parameter as loan status. And this divides the graph like this. So from this graph we notice that as the grade goes from A to B and B to C, like that the default rate increases. And if you are beginner, this is something you may not understand initially, but don't worry, I have another way of getting this thing in the percentage. And for this, we are going to write a query that involves filtration of the data. So we are going to do this thing step by step. So first we are going to filter the data based on the grades. So let's do it for A. So first we are going to call the data set and then we are going to use the square bracket, and inside that we are going to call the grade variable and then we equate it equals to A. So here we see that we only have those data points where grade is A. So it's like we are subsampling the data set based on certain condition. And in this case, the conditions are based on grading. And now on top of this, we are going to call group by function and group the data according to loan status. And this is because we want to know the loan behavior, that whether the person is paying the loan or defaulting based on the grading. So if we try to run this cell, we are going to get this kind of output. So basically it's an object. Now on that we are going to call our grade variable, and on top of this we are going to call our count method. So here we get the count of how many people pay the loan and how many did not, considering only grade A loans. And that's exactly we tried to explore in the above graph. Now to get the more information out of it, we need to change it into percentages. And to do that, we just have to multiply it by 100 and divide it by the length of the dataset. And here we are not going to consider the length of the actual dataset. We need only those data points where the grade is equals to A. So we are just going to copy paste this thing and rerun the cell. So now here we have more information. That is, if we consider only grade A type loans, the percentage of people defaulted is 6%, whereas approximately 94% people paid off their loans. And now we can use the same code to get the information about other grade of loans as well. So we just have to change A to B and see the result. So here we see that the default percentage is 12%. Similarly, let's check for G as well. And here we see that it is 47%. So now it is safe to say that people from this category are more likely to default. So now here you can see the trend that as we go from A to B or B to C, we see this trend that the charge of percentage is increasing. Now I would suggest you to do the same for all the grades. This way you will get the more clarity with the code and the data. Now on similar lines, we are going to check for subgrade. So let's see what this variable is. So now here we see it takes some bunch of alphanumeric values. Now let's see how many unique values this variable can take. So here we see that it is subgraded using the grade variable by providing some numerical value after each grade. So now we are going to plot the count plot again. So we are going to copy paste the same code, just we are going to change it to subgrade. So here we have the graph, but this graph does not look representable. So to make this representable, let's do few things. So first let me add a cell above. So first we are going to create a suborder variable, and in that we are going to create a sorted list of subgrade by using sort function provided by the Python. And then we just have to call our subgrade variable, and on top of that we are going to call our unique method. So now let's see how it looks like. So let me add a new cell, and then we are going to call our suborder variable. So you see it has sorted this thing like A1, A2 and so on and so forth. Next we are going to use this list in our existing graph, and how do we do that? We just have to call this parameter called order, and in that we have to pass this suborder list. And now we see this beautiful graph which looks more representable, and from here we can see that we have less data point for bad grade loans or bad subgrade loans. Now if you want to do in-depth analysis of this variable, you can use the previous query. It is just you have to copy paste it and change the grade to subgrade, and then you have to pass the subgrade. And I would highly encourage you to do this because this is going to give you a lot of detail that you can pitch in your interview. Next, we are going to check how the employee length affects the loan status. So we are just going to copy paste the code and we change the grade to employee length. So here we have our graph. Now your task is to sort this graph according to the year of experience and try to run the same query to check the percentage distribution for each class. And this shouldn't be hard for you now because we have already talked about these two things. So just try it yourself. So next we are going to check for the verification status and the loan status. So just copy paste the code. And now let's change the variable name to verification status. And now if you look at this graph, we see a shocking thing that the distribution for the not verified, source verified and verified is almost similar. So why did I say shocking? Because the graph is telling us the company verification process is not as efficient as it should be. Had it been the case, we would have been able to decrease the charged off count in case of source verified and verified. So now we can advise the company on the basis of this graph that the verification process is not much effective and there should be some amendments in that. So as of now, we have fully paid and charged off as a target, but we want them into 0 or 1 because we know that our algorithm will not be able to understand this. So for that, we are going to use lambda function on the variable. So first we are going to call our .apply function, and inside that we are going to write a lambda expression. So lambda x, then colon, and then we have to pass the condition. So 1 if fully paid, else 0. And now here you can see that we have assigned 1 and 0 according to this condition. So let's make the change into the actual data set. Next, we are going to look for the correlation of loan status with other variable. And this is one of the reason why we converted it to a numerical format. So we are going to call correlation method and we get this kind of result. So this is the matrix. Now we only want the correlation of loan status with other variable. And for that, we just have to call the loan status. Now here we have the correlation of loan amount with other variables. So we can sort this by calling sort values method. And now we have the result in ascending order. So what we can do, we can drop the loan status variable because obviously the correlation of loan status with loan status is going to be 1. So on top of that, we are going to call plot method, and inside that we are going to plot the kind equals to bar. So this gives us the bar plot of correlation values of other variable with the target variable. So now if I try to drop this loan status variable, what will happen? We will get this also in the graph. And it's good idea to remove this variable because it does not make any sense, because the correlation of a variable with itself is going to be 1. It's not going to impart any knowledge or any result for us. It is just that I wanted to show you how the graph will look like if you include the loan status. So that's all for this video from my side, and I hope you enjoyed this analysis. And if you are new to the channel, please do like and subscribe and press the bell icon for the future update. So see you in the next video. Till then, bye, wear a mask and stay safe.